we are still on the concept of friction, and this one shows us an inclined plane with two blocks placed on the plane, and over here is a frictionless pulley. This is a frictionless pulley. And on this frictionless pulley is connected a rope. The rope is connected to two other blocks, Y and Z. The mass of block Z is 15 kg. The mass of block Y is 5 kg. The mass of block X is 20 kg. The mass of block M is 10 kg. Now, the tension force is acting on this rope. This is 60 degrees. From the diagram above, calculate Roman figure 1, the acceleration of the system, Roman figure 2, the tension T in the string. And the acceleration to gravity is given as 10 meters per second square. Okay, so let's solve that problem. Alright, let's solve that problem. That is it. As the question given to us. Okay, observe it clearly. As the question given to us. Asked to find the acceleration of the system and the tension T in the string. So we'll start with block M, later we'll go to block X, later we'll go to block Y and consider block Z finally. Okay, let's do that quickly. I say consider block M. If I consider block M, I'll have something like this. Okay, this is 60 degrees. Then on this is placed a block. Okay, and the weight of that block will act vertically downwards. The weight W will be equals to mg. The mass of the block is 10 kg. That's 10 kg times 10 meters per second square. So 10 times 10 will give us 100, which is 100 Newton. The weight of the block is 100 Newton. Okay, it's acting vertically downwards. Now the next thing I'll do now is to find the normal reaction. This is at 90 degrees. Okay, so this is my normal reaction arrow. Okay, normal reaction arrow. Then this angle here will also be 60 degrees. We assume that the angles are on the same segment. So that's also 60 degrees. Now we'll resolve this weight this way. Resolving it like this, I'll have 100 cos 60 degrees. That is the weight, which is 100 Newton. That is the cosine of this angle, 100 cos 60. And I'll resolve it parallel to the plane. Resolving it parallel to the plane, I'll have 100 sine 60 degrees. So I resolve it parallel to the plane, just like this, and perpendicular to the plane. Perpendicular to the plane is 100 cos 60. Now you also observe there is a rope attached to that block, and to that rope is my tension force acting on that rope. Okay, that is it. This is it. At this rope here, there is a tension force that will act on this rope, tension T. Okay, that's what I just got there. Okay, so that's the tension force acting on that rope, and then this one is showing you the resolution of the force. When we resolve the weight acting parallel to the plane is 100 sine 60, and perpendicular to the plane is 100 cos 60 degrees. Okay, now there was no coefficient of friction given to us, so there's no need indicating the frictional force. Okay, so we'll leave it at that. Now we'll look at the upward perpendicular force equals to downward perpendicular force, which that one is Newton's third law of motion. It shows that action and reaction forces are equal and opposite to each other. So applying Newton's third law of motion, I'll say the upward perpendicular force is equals to the downward perpendicular force. Okay, so the upward perpendicular force is this one, the normal reaction, and the downward perpendicular force is 100 cos 60. So I'll say my normal reaction arrow is equals to the downward one, 100 cos 60 degrees. Okay, and cos 60 is 0.5. So my normal reaction arrow will be 100 times 0.5. 100 times 0.5 is 50. my normal reaction is 50 Newton. Okay, that's the normal reaction. Now apply Newton's third law of motion, second law of motion, sorry. Apply Newton's second law of motion to this block. I'll say here is positive x, and if it's coming like this, if it's coming this way, it's negative x. So the upward parallel is positive x, and the downward parallel will be negative x. So that means my tension will be positive, and this one will be negative. So you say applying Newton's second law of motion to block M. Apply Newton's second law of motion to block M. Okay, apply it to that block. I'll be having, okay, so that is Newton's second law of motion. F prime will be equals to MA. And then I'll say this one going here is positive. Tension force is positive plus, this is showing us the summation of forces is equals to the mass times acceleration. So the tension force is positive, and this one coming downwards like this is 10 sine 60, which is negative. That's the sign convention. Negative here is positive. That'll be minus 100 sine 60 degrees, because to the mass of that block is the mass of this block is 10 kg. That'll be 10 times A. 10 times A. So this now is T plus times minus is minus, as T minus 100 sine 60 degrees is equals to 10A. Okay, so sine 60, T minus 100 sine 60 is 0.866. Is equals to 10A. Okay, so if I multiply it now, I'll be having a T minus 86.6 is equals to 10A. Alright, so this is T minus 86.6 equals to 10A, which I can call this equation 1. Alright, okay, so that is it. This tension force going like this. Okay, positive T, and this one coming like this is negative minus 100 sine 60. Finally, I'm having T minus 86.6 equals to 10A. Now then, consider block X. Say consider block X. This is block X. I'll take this surface, take the inclined surface, which is 60 degrees, and I place my block over there, and then the weight of that block acting vertically downwards is W equals to mg. So W will be, the mass of the block is 20 kilogram, acceleration to gravity is 10 meters per second square, so W will be equals to 200 newtons. Okay, then I'll look for the normal reaction. The normal reaction will act at 90 degrees to that surface, that's at angle 90. Okay, at angle 90 I'll have this, I have my normal reaction arrow. So that means that I'll take this, if here is 60 degrees, this angle here is also what, 60 degrees. Resolve this one this way, and I'll be having, this is 200 cos 60 degrees. So I resolve it like this, 200 cos 60 degrees, and I resolve this one this way. Resolve this one this way. I'll have 200 sine 60 degrees. So what I did was to resolve it perpendicular to the plane and then parallel to the plane, and I had that. Okay, so I will also consider the tension force that is acting on this surface. Tension force acting on the surface of the rope. I'll take it. So there is a rope there, the rope is attached there, and then the tension force is acting. That tension is tension T. Okay, alright, so that is it. So I've resolved this 200 cos 60 perpendicular to the plane and 200 sin 60 parallel to the plane. Okay, so the next thing I'll do now is to find the normal reaction. Normal reaction, upward perpendicular force will be equivalent to the downward perpendicular force. So I'll say the upward perpendicular force is equivalent to the downward perpendicular force. Okay, so now I'll take the upward one, which is arrow, and the downward one is 200 cos 60. And that will give me, okay, so now look at the upward perpendicular force equals to the downward perpendicular force, which is the normal reaction, equal to 200 cos 60. This is downward, this one is upward. So my normal reaction will be equals to 200 cos 60 degrees. So I'll take the upward one, upward perpendicular force. This is downward perpendicular force. Okay, so this is arrow equals to 200 times cos 60 is 0.5. So 200 times 0.5 will give me 100 newtons. This is my normal reaction. Now, applying Newton's second law of motion, you say applying Newton's second law of motion, Newton's second law of motion to block X. So if I apply Newton's second law of motion to block X, say that the summation of forces is equals to mass times acceleration. This F prime here shows us the summation of forces, as in sigma F. You can say sigma F is equals to ma. That's what it means. This F prime shows you the summation of forces. Shows you the summation of forces, okay? Shows us the summation of forces, sigma F. Okay, so let's go back to that diagram. It means that using our sign convention, this is positive X, and this one coming down like this, parallel to the plane, coming this way is negative. So here is 200 sin 60 is negative, and tension force is positive. Okay, so those are the parallel forces we need. Tension T, which is positive, plus this one, which is negative, that will be minus 200 sin 60 degrees, equals to the mass of this block. Mass of the block is 20 kg. If you observe, the mass of block X is 20 kilogram. That will be 20 times my linear acceleration. Okay, it's 20 times linear acceleration A. So this now will be T, plus times minus is minus, that's minus 200 sin 60 degrees is equals to 20 A. Okay, so sin 60 now, this is T minus 200 sin 60 is 0.866, which will be equals to 20A. So 200 times 0.866, what will it give me? To give me so 200 times 0.866 will give me this will be 173.2. That is T minus 173.2 is equal to 20A. Okay, it's T minus 173.2 is equals to 20A. So, which I can call this one equation 2. 173.2 equals to 20A. Call this equation 2. Okay, then I will then consider block Y. Say consider block Y. Block Y now is this. I'll look for the weight of the block. The weight of the block is its mass times acceleration due to gravity. So the weight now is, the mass of the block is 5 kilogram. Acceleration due to gravity is 10 meters per second square. So that means that W equals to 50 Newton. That's the weight of block Y. Okay, this is block Y. This is the mass of the block, 5 kilogram. So when we are done with block Y, we'll look at block Z. Okay, quickly, let's continue. Now, there is a rope attached to this block, and the tension acting on that rope is tension T. That's the tension acting on the block, on the rope, sorry, tension T. Alright, so then we'll look at the sign convention. Acceleration due to gravity is is coming downwards. Okay, so it's coming downwards. That show you the direction of motion. It's coming downwards. So that means that my sign convention now changes. This is plus y, and going up will be what? Minus y. Okay, so see, this is showing you the direction of motion. Impending motion is downwards. So since it's acting downwards, that means any object acting due to gravity is what? Positive. And the one going against gravity will be negative. Okay, so this one coming like this is acting due to gravity is positive, and this one is going against gravity is negative. So that is, tension will be negative and the weight will be positive, positive y. So applying Newton's second law of motion, I say that F prime is equals to what? Ma. Okay, that's Newton's second law of motion. Okay, so the F prime there is showing us the summation of forces. This is showing us the summation of forces. So that's, I'll take that one now as negative T minus tension. Okay, based on the sign convention, and this one is positive W. Positive W is equals to the mass of that block is 5 kg. That is 5 times linear acceleration. 5 times the linear acceleration. So this one now will be minus T plus the weight of the block is 500. Weight of the block is 500 Newton. That is plus 500 equal to 5A, which I can call this equation 3. Okay, I'll call that equation 3. Alright, now the next thing I'll look at is block. Is the next block, that is consider block Z. Consider block Z. Okay, and this is the block. I'll quickly find the weight of the block. Weight is acting downwards, and also there is a rope attached to it, which I'll find the tension acting on that surface of the rope. Right, so this means the weight W is equals to mg. Weight is equals to mg. Okay, so let me show you quickly the block I'm considering. The block is Z. This is the block I'm considering, block Z, which the mass of the block is 15 kg. There is a tension force that will act on this surface of the rope. Tension will act on that surface of the rope. That's tension T. Okay, that was how I got this free body diagram. The weight acting downwards and the tension force acting on the surface of the rope, tension T. Alright, so I'll first find the weight of the block. The weight now is this mass times acceleration to gravity. Okay, it is the mass times acceleration to gravity, which is the mass of the block is 15 kg times 10 meters per second square. Okay, mass is this, acceleration to gravity is this. That's what, 150 Newton. Okay, so that is the weight of the block, is 150 Newton. So the weight of this block is its mass times acceleration to gravity, weight of this block. So I have this 150 Newton. Now the next thing now I will look at is the sign conventions there. This sign convention here is a positive y, and here is a negative y. Okay, I explained that before. Why? Because acceleration to gravity is coming downwards. So A is coming downwards, which is what? Plus G. If it is coming downwards, it is what? It is acting due to gravity. If it's coming downwards, it's acting due to gravity. If it's going upwards, it's against gravity, negative. So this is negative T, and this will be positive W. So applying Newton's second law of motion, you see, from Newton's second law of motion, you have F prime is equals to what? Ma. That's Newton's second law of motion. Okay, so that now will be summation of forces is equals to its mass times acceleration. So my tension force is negative and my weight is positive, equals to the mass of the block is 15 kg, 15 times its linear acceleration. Okay, so that is minus T plus the weight of the block. We had the weight of the block as 150, that is plus 150 equals to 15A. 15 times A is 15A. So I can call this one equation equation 4. Call this equation 4. Okay, so this is equation 3. Minus T plus 500 equals to 5A. That's equation 2, t minus 173.2 equals to 20a. And equation 4 is t minus t plus 150 equals to 15a. Alright, so now the next thing I'll do is I'll come back to this system of forces. Now you see that this block M and block X are placed on the same inclined plane. So I'll add their equations. Block M gave us equation 1 and block S gave us equation 2. Okay, now add the equations, and you see over here the y block and the z block give us two separate equations. This one give us equation 3 and this one give us equation 4. So I'll add the equations. Okay, after which I'll then solve simultaneously. So let's add the two equations of this. That is, say equation 1 plus equation 2. This is equation 1 gave us t minus 86.6 equals to 10a, and equation 2 gave us t minus 173.2 equal to 20a. So if I add them now, I'll be having t plus t minus 86.6 plus minus 173.2 is equals to 10a plus 20a. So t plus t is 2t. Plus times minus is minus. That is minus 86.6 minus 173.2 is equals to 10a plus 20a is 30a. So if I tackle that now, minus 86.6 minus 173.2 will give me is minus 259.8 is equals to 30a. This is 2t. Now I can call this one equation 5. Okay, I can call this equation 5. That's 2t minus 259.8 equals to 30a. I can call that equation 5. Right, so now the next thing I'll do now is to tackle what's it called? Equation 3 and equation 4. I'll say equation 3 plus equation 4. That will be equation 3. I'll write equation 3 out. Equation 3 is this: minus t plus 500 equals to 5a. Then this is equation 3. And equation 4, I'll write equation 4 out. Equation 4 is minus t plus 150 equals to 15a. Call that equation 4. So if I add them, we're having minus t plus minus t plus 500 plus 150 is equals to 5a plus 15a. That is 5a plus 15a. Okay, so plus times minus is minus, and that will give me, so plus times minus is minus. Okay, so this now will be minus t, then this is plus 500 plus 150 is equal to 5a plus 15a. So minus t is minus 2t. Okay, 500 plus 150 will give you 650. Okay, it's equals to 5a plus 15a is 20a. I can call this one equation 6. Alright, so then I will tackle equation 6. It says solving 5 and 6 simultaneously. So if I solve 5 and 6 simultaneously, I'll have let's copy equation 5 out. Equation 5 now is 2t minus 259.8 is equals to 30a. It's equation 5. Equation 6 is minus 2t plus 650 is equals to 20A. This is equation 6. Alright? Okay, that's it by the way. Okay, now the next thing we'll do now is just to add the two equations. As if I add them, I'll have, say, equation 5 plus equation 6. So 5 plus 6. If I add them now, I'll have say equation 5 plus 6. That will give me 2t plus minus 2t, then minus 259.8 plus 650, as this plus this, equals to 30A plus 20A. So plus times minus is minus, that's 2t minus 2t. And I'll then tackle this one, minus 259.8 plus 650 will give me, so this will give me plus 390.2. So equals to 50A. So 2t minus 2t is 0. So cancel out. So I'll be having 390.2 is equals to 50A. I'll make A subject of formula by dividing by the coefficient. The coefficient of A is 50, so I'll divide by 50. I divide by 50, I'll be having A equals to 390.2 divided by 50. And my acceleration A will give me, I divide, I'll be having, so this will give me 7.804. So the acceleration A will be, linear acceleration is 7.804 meters per second square. Okay, and 7.804 meters per second square is the linear acceleration. Okay, now I've gotten the linear acceleration of the system, so therefore the acceleration of the system, as the linear acceleration of the system is 7.804 meters per second square. Okay, now how do I find the tension? To find the tension, I say substitute A equals to 7.804 meters per second square into equation now I can make use of equation 5 or equation 6. Let's use equation 5 into equation 5. So equation 5 is 2t minus 259.8 is equals to 30A. Okay, so now this now will be 2t minus 259.8 equal to 30 times A is this 7.804. Okay, so this is 2t minus 259.8 equal to, if I multiply that, what will I have? I'll be having a, okay, so when I multiply 30 times 7.804 gave me 234.12. That is 234.12. And I multiply, I'm having 234.12. That is this times this. Then I can collect like terms. By collecting like terms, 2t, this minus 259.8 will cross over here to change to plus, will be equals to 234.12 plus 259.8. 2t is equals to, that is this now be having 493.92. Then I'll divide by the coefficient of t. Coefficient of t is 2. T will be equals to 493.92 divided by 2. I divide by 2 now, I'll be having 246.96 Newton. So therefore, the tension in the string is 246.96 Newton. That's the tension. 246.96 Newton. Okay, and the acceleration of the system is 7.804 meters per second square. This is the acceleration of the system. Okay, is this 7.804 meters per second square. Okay, is the acceleration of the system. Acceleration of the system. The acceleration of the system is this 7.804 meters per second square, and the tension in the string is 246.96. So just observe the steps we took finding the tension, and also the steps we took in finding the acceleration. Find the acceleration of the system. Okay, using Newton's second law of motion, all the steps we took. Now we arrived at simultaneous equations and we solved. Okay, so that is it. We'll be stopping here for today. Stop here for today. Once again, this is Physics Made Easy by Prosper Nodi. Physics Made Easy by Prosper Nodi. This question we solved was on friction. Physics Made Easy by Prosper Nodi. Okay, we solve questions on physics, mathematics, and further mathematics. Please do well to subscribe to this channel if you have not subscribed, and also share with your friends, students, even in other schools. Share with them. Preparing students for WAEC, NECO, and JAMB exams. Okay, to prepare them for WAEC, NECO, and JAMB before they can get into higher institutions. Please make sure you share this video. It will benefit you and your friends a lot. Please. All right. Thank you very much. Thank you. We'll be stopping here for today. This is Physics Made Easy by Prosper Nodi. Physics Made Easy by Prosper Nodi. Okay, Physics Made Easy by Prosper Nodi. Alright, thank you. God bless you.